Okay, so let's look at trigonometric limits. There are two that you need to look at. The first one is the limit as sine of x over x. X goes to 0. That one always equals 1. And the other one is the limit as x goes to 0, 1 minus cosine x over x equals 0. So these are two that you need to memorize. There's just no question you're going to memorize them. But what we're going to do is we're going to look at them graphically so you can see exactly how they work. So remember what we did before when we set up a trig table or a table so that we can plug in the values and see what's going on. So what I'm going to do is I'm going to open up your calculator and we're going to put in there the function. So we're going to graph it. And we're going to, first of all, make sure that you're in radians. So we're in radians, and we're going to put the graph of y equals sine x over x. Okay, so we're going to do sine x. So sine x, and that's going to go over x. Okay, we're going to enter that in there. Okay, so you can see the graph right here. Okay, and we're looking to see what's going on at 0. Now you can see on the graph, it looks like it has a left limit and a right limit that are approaching a value. And let's just double check what that is by going to our table. So Control T, there's our table of values, and let's just double check what we've got over here. So we're looking for -1, -0.5, -0.1. So let's put those values in so we know exactly what we're doing. So over here, remember how to do this? You've got to go to the menu, table, edit table settings, make sure this one is on ask, hit OK, and let's enter the values in there. So let's check, let's do -1 first. So -1, get a value, then -0.5, -0.5, -0.1, -0.01, -0.001, and -0.0001. Okay, so look over at the table here and you can see here come your values. They're getting closer. This one's getting closer to 0. This one doesn't look like it's changing much. Let's see if we can go one more. -0.00001. Is it going to get me anything closer? That still looks like it's not going very far. Oops, you know what I'm noticing? I'm noticing that it's degrees over here, so I maybe need to change that. So let's do the document settings. Oops, sorry. Let's go document settings. How that change to degrees, I don't know. Let's make sure it's in radians. Okay. Is that going to change my value? Doesn't look like it's changing anything. So we might want to, there we go. Okay, so it changed it all. So you can see now what's going on. Okay, so as I move closer towards 0, the values get closer to 1. And then I can do the other side of the graph as well, coming from the opposite direction. So we're going to do 1 and then 0.5. So we're getting closer from 0 from the other direction. 0.1, 0.001. And again, you can notice as you get closer to 0 from that side, it also approaches 1. So that's the proof that this function, the limit as x goes to 0 of sine x over x, approaches 1. Okay, so we'll just put that in there right now. So this should equal, oops, hello, little guy. Uh-oh, he's not wanting to do anything. Let's do there. There it goes. Equals 1. Okay, so you can do the same thing with the other function, which is the 1 minus cosine over x, cosine x over x, and let's check out what that one's doing. Okay, so again, we're going to go into the graph, and we're going to see what it's doing there. Okay, so here's the graph again, and we're going to add a new graph. Okay, plus page, I'm going to add a new graph. And we're going to, again, put in 1 minus cosine x over x. So 1 minus cosine x, and over x. And you can see the graph. There it is. And if you look at it, what's happening as you get close to 0 from the left and the right, you can see it here getting close to 0. And you can also check the table. So you want to Control T, that one, like it's asking you to do, putting in some values here, and make sure you're still in radians. You need to ask what the values are. So you remember Menu and Table and Edit and Ask for that one. And over here, put your values in. So you have -1, get closer, -0.5, get closer, -0.1, get closer, -0.01. Okay, and you start to see that the values on the right, the limit's getting closer to 0. Okay, so as I get close from the left side, it's 0, and then you can do the same thing on the right side, enter the values on the other side. So 1, and then 0.5, 0.1, 0.001, and 0.0001. Okay, again, getting close to 0, getting close to 0 on this side. Okay, so that one is also easy to prove. Let's put that one in here. Okay, so this one right here, again, the limit as x goes to 0 of 1 minus x over x is also 0. Okay, so the first one was equal to 1, and the second one's equal to 0. Okay, now how do you use it? What do you do with those when you prove these things? So here's what you've got. You've got these functions, or these equations, and you want to break them down so that you can get it to be one or the other of those two formulas. Okay, you've got the two formulas, sine x over x going to 1, or 1 minus cosine x over x going to 0. So you start switching things. So tangent is the same as saying sine over cosine. So replace tangent with sine over cosine, and the x is still in the denominator. And now you're going to top divided by bottom is like saying the top times 1 over the bottom. And you put the sine x and the x together. Okay, so you put those two. This one you want to put together with this one when you rewrite it. So it looks like that, because those are the two that work with the formula. And the 1 over cosine x is just there. So sine x over x goes to 1. And over here, the thing is 0 in cosine. If I just put 0 here, cosine of 0, if that's a 0, cosine of 0 is 1. So that's 1 times 1, which means the answer is 1. So you just have to make it work to one of those formulas and see if you can get it to break down. So look at the next one. You've got trying to find the limit of 5x over x. Okay? So what I like to do is I like to break the two, the numerator and the denominator, up. So you got 5x, and then you make 1 over x. Just move it apart a little bit. Same thing. That's just another way to write it. And what you always want to try to do, if you look at the formula, it's sine of x over x. So I want to get those two to be the same value. So I have a 5x here. I need a 5x in the denominator. So I'm going to put 5x over 5x, because what does this just equal? That's just 1. So I'm not changing the value of anything, but I'm manipulating my equations so that then I can rearrange all of this to put 5x, sine 5x over one of my 5x's, and then the other one is still on top, but it's over an x. And then this one, the limit of sine 5x over 5x goes to 1. That whole thing goes to 1. And then 5x over x just reduces to 5. So I end up with 5. So my ultimate limit is 5. So you're manipulating this so that it works. Okay. Let's take a look at the next one. Okay, so here's one that we could try. So the first thing you want to do is you want to try to break it up. So let's see if we could get this to work. Okay, so let's break it up. Let's say sine x, sine of 6x over 1, and then 1 over sine of 2x. So I just broke it up a little bit. Okay, now to make it so that it follows the formula, I need to add something on the top and the bottom so that it's the same value. So for this guy, I need a 6x on the bottom, which means I need a 6x on the top because I need it to not change the entire value. So whatever you do to the bottom, got to do to the top. This one, because the inverse of the formula is the same as the original. So it doesn't matter if it's x over sine x or sine x over x. So this one, to make it work, needs a 2x. If I give it to the top, I got to give it to the bottom. Okay. So now when you look at it, I've got this one going to 0. So that whole thing is going to end up going to 1. This 2x over sine 2x is also going to 1, according to the formula. And this 6x over 2x reduces to just 6 over 2, which is 3. So the limit is just 3. Okay? Let's look at the next one. All right, so this one, I'm going to do the same thing. I'm going to go x over 1, and then 1 over sine 4x. Just split it up like that. And let's take this one. To make it look like the formula, I need a 4x on the top. And if I give a 4x on the top, I got to give a 4x on the bottom. And let's give it over here, because it makes sense to put it on that side. And so I haven't changed the value at all. But this whole part right here goes to 1, according to the formula, and the 1 over here reduces to 1/4. So that would be your limit. Okay. So last one. Let's see what we got here. Okay. So we have tangent of 3x. So what I'm going to do is I'm going to write tangent as the same as saying sine of 3x over cosine of 3x. Okay, and that's all divided by 2x. So that's the same as saying 1 over 2x. Okay, so far. So let's split them all up. So we've got sine of 3x over 1 over cosine of 3x, and a 1 over 2x. Okay, so I didn't change the value. I just split everything up, moved it around a little bit. All right, so then what we've got is this one needs to be fixed, so it needs a 3x on the bottom. If I give a 3x on the bottom, I got to give a 3x on the top. And 0 into cosine isn't a problem, because the cosine of 0 is 1. So I don't need to do anything to this. It was just the sign that's weird. So now, limit as x goes to 0, this whole piece goes to 1. 0 in here means cosine of 0. That goes to 1. And this piece right here reduces to 3/2. That's your answer. Okay? So that is how you're going to solve them. Now, they can get a little trickier. And I have an example here of the next set where you have to do a little bit more manipulation because the 1 minus cosine 1 is a little bit trickier. So if you look at this one here, you've got 1 minus cosine 3x over x. So what I did is I split it up like the one before. Split it up. Value hasn't changed. I need it to be xx or 3x, 3x. Whatever's here should be the same that's in the denominator. So this one has a 3x, so I need a 3x in the denominator. So I gave it top and bottom 3x. So I moved one of them here, one of them here. This piece of it, all of this is 0. That's just 0. And 0 times this one that's reduced, 0 times 3, is just 0. Okay? So it's a little trickier with the cosine rule, but it's the same idea. You're just trying to manipulate it. Okay, so let's try this one. All right, so again, let's split it up. And it doesn't matter that it's cosine 4x minus 1 or 1 minus cosine. Let's do it this way. Split it up like that. Okay, now if it makes you feel better to switch this around, let's move it this way, cosine of 4x, and that just means I did a -1 outside. Okay, so then that's over 1, and it's got 1 over x. And then to manipulate it to what I want, it needs a 4x in the denominator, which means it needs a 4x in the numerator